Today, this is your favorite math tutor, DKA Math Tutorial. And if you have not subscribed to my channel, please kindly subscribe to my channel for more content. Today, I'm here to take you through variation. And so, it's one of the topics in core maths which is very, very important. So far as West Africa examination is concerned. And most at times, questions being set on this, and students find it difficult to understand. So kindly pay attention and follow, and everything will be easy at the end of the day. So first of all, let's start with variation itself. Somebody will ask, what is variation? Variation simply is the way in which one quantity changes in relation to the other quantity. It simply means what? A way in which what one quantity changes in relation to what? The other quantity. And I will explain it when I'm explaining the types, and you get to understand it more further. So without wasting my time, let's name the types of the what? Variation. We have three types of what? Variation. We have three types of what? Variation. So let's bring the types of variation. So types of variation. So we have one type of variation which is direct. Then two, we have the indirect. The third one, which is joints. So the indirect, some textbooks or some professors or some teachers may also write the inverse variation, which is still the same. So whether you see inverse variation or indirect variation, they are the same. Then you have the joints variation. Now, these are the types of variation we have, and we are going to take it one after the other and treat it into details so that you get the concept very well. So let's take the direct variation. So direct variation. So what's the direct variation? So direct variation is mathematical relationship between two variables. Where one variable is dependent variable. So it's a mathematical relationship between two variables, where one variable into bracket dependent variable is a constant multiple of the other variable. Is a constant multiple of the other variable. This one, that one can be the independent variable. So it's a mathematical relationship between two variables, where one variable into bracket dependent variable is a constant multiple of their other variable. That's what dependent. Now let me go on and explain to you. So way back DHS, we normally have something like 1, 2, 3, 2 to let's say 6, 3 to let's say 9, 4 to 12. And you see that there's something we written here, domain. then you see the corresponding values will be codomain. Now, according to the definition, they say where one variable is dependent and the other variable is the constant multiple of the what? The other variable. So the definition is telling you that when you take the first variable, multiply by a certain value, it will give you the corresponding what? Variable of the values. Are you okay? So we have these small values here. When these values here is being multiplied by one constant value, it will give you the rest of the what? Its corresponding what? Codomain. So for instance, if I multiply this one by a certain number, I will get what is its corresponding value. If I multiply this one also by a constant value, that same number, I have to get this. If I multiply this one also by the same number, I have to get this corresponding what? Codomain. So for instance, what number should I multiply to 3 that I will get this? This is 1 times what? 3. And it will give me what you have here. So which is 3. If I multiply this 2 here, also by 3, it gives what we have here. If I multiply this 3 here, also by 3, it gives me what we have here. If I multiply this 1, also by this, it gives me what? This. Are you okay? Somebody also might be asking, if you want to also do the same here, if I take the values here, divided by a certain value, I have to get what we have here. Are you okay? So for instance, what should I do to this 3 to get this one? If I divide this 3 by itself, I have to get this one. So if I take 3 divided by 3, I have to get the corresponding value here. If I also take this 6 and divide it by the same 3, I have to get the corresponding value here. So if I take this 6 divided by 3, I have to get the corresponding what? Value here 2. If I take this 9 divided by the same 3, I have to get the corresponding what? Value here. If I take this 12 here, this 12 I have here, and I divide it by the same 3, I have to get the corresponding value here, which is 4. Are you okay? Now, let's write the formula. Are you okay? Let's write the formula for direct variation. In writing the formula, we take the codomain. Are you okay? Which is the value for y. As you know, this are the coordinates for what? S values, and these are the coordinates for what? Y values. Are you okay? So if I want, how did I get these values? If I take the constant divided by the y value, then I'll get the coordinates for s, isn't it? Now if I want to write the formula, therefore I can say that x equals to y. Have you seen this? You always take the y. Are you okay? Equal to y divided by what? That normally gives us s. Divided by a certain what? Constant. Are you okay? So divided by the constant k. Are you okay? So whenever always you take y divided by the constant k, you get your what? Your s values. Are you okay? So this is the formula for the direct variation. This is the formula. So now let's take examinable question and solve for more understanding. Now in variation, whenever you hear varies, you introduce a variation sign, and this is the variation sign. So let's write. We are still on the direct variation. We are still on the what? Direct variation. So let's write a question for example 1. Example 1. So example 1. R varies. R what? Varies directly, because we are dealing with what? Direct variation. Directly with V. Why what? R varies directly with what? V. Where R is equal to 125 and V is equal to 5. Find V. What? Find what? V. Find V where R equals 8. So this is a question. You can pause the video. You can pause the video and try to solve it on your own. But let's solve this one together. Then maybe the second question, you can pause the video and try to solve it on your own. So let's see. So there's an R value. So you introduce the variation what? Sign. Directly with what? V. So you introduce your V. Because you see direct variation is a mathematical relationship. There's a connection between two variables. Where this variable is a constant multiple of the what? The other what? Variable. Are you okay? So where R is, then you introduce. It's a constant multiple. Then you introduce a constant multiple of the what? The other variable. So you multiply the other variable by what? A certain what? Constant. Are you following? Now from here, we can calculate or we can solve for what? K. That's the constant. We can solve for the K or we can find the what? The K. So in finding the K, we divide both side by the what? The variable that is attached to the what? K. Are you okay? Or the coefficient of the what? K. So you divide both sides. So you divide both sides by what? V. So we move on to the next line. Divide here by V. Also by V. And the V cancels. Therefore, we have K equals to R over V. And now we have to solve for what? Our K. Now we have been given R in the first preamble. They show where R is equal to 125 and V is equal to what? 5. So we will substitute those values here to find for our what? K. So we say where from the question where R is equal to 125 and V is equal to what? 5. So let's substitute those values inside here and solve for our what? K. So we are going to have K equals to 125 over 5. So therefore our K is equal to 25. So after you have gotten the K, then you substitute the K back into the equation you have here. After you have gotten the K, substitute the K back into the equation you have here. So you are going to have R equals to 25 times what? V. Now the question says you should find what? The question says you should find V. Where R is equal to what? 8. So therefore, they say we should find V here. So if you have to find V, you should make V the what? Subject. So if you have to find V, then you find both sides by the coefficient of what? V. So we are going to have R over 25 equals to 25 to V over what? 25. This one will cancel this. Therefore, we have V equals R over 25. Now they said we should find V. Now V is equal to this, but they said where R is equal to what? 8. So all that you need to do is to what? Substitute that R what? Back. So therefore V is now equal to 8 over what? 25. And that's all. So this is the example 1. So we are going to take example 2. and the example 2. So let's write example 2. So let's write example 2. Example 2. Example 2. Y varies. Y varies directly as the key root. Y varies directly with the key root of x. Y varies directly with key root of what? X. And the key root is here, like this. Key root of x. Y varies directly as the key root of what? X. Where x is 27, where x is 27, where x is 27, and y equals to 3, and y equals to, so the question is on the board, let me write it. So y varies directly with cube root of x, where x equals to 27 and y equals to 3. Find, so we should what? Find y. Find y. Where x equals to 8. Find what? Y. Where what? X equals to what? 8. So the first time we are not able to get the question correctly, the question is now on the board, and as you are watching, you can pause the video small and try to solve it on your own. So now let's solve it together. So as you know, the first variable, you write it down. It said y varies. Then you introduce the variation sign. Directly with the what? Key root of what? X. Key root of what? X. But as you know, they said direct variation is where the first variable is. So this is the first variable. Is. Then a constant variable of the other. So we introduce the what? A constant of this. Are you okay? Now from here, we can solve. They say we should where x is equal to what? 27 and y is equal to what? 3. So if you want to still make the subjects, now we want to find k. So how are we going to find k? You can divide both sides by the cube root of x, right? So we divide here by cube root of x, here also by cube root of x. That's what we have here. And this cube root will cancel, cube root of x will cancel cube root of x. And we have k equals y on cube root of what? X. But in the question we are given what? X to what? 27 and y to be what? 3. Wherever we see x, we put 27 there. Wherever we see y, we put what? 3 there. So we are going to have k equals to y, which is what? 3 over cube root of x, where x is what? 27. So k then now equal to 3 And cube root of 27 will give you what? 3. Now 3 will cancel itself and leave you what? 1. 3 will root itself 1, cancel your 1. So which was 1. Therefore our k now is equal to what? 1. Once you have gotten your constant value, you go back to the question and substitute k back. So the equation was y equals to k multiplying to the cube root of x. Now we have gotten k. Therefore substitute what? K back into the what? Equation. So we have now have y equals 1 multiplied by cube root of x. So and as you know, 1 multiplied by any number or any value is still the same. So we therefore have y equals to cube root of what? X. That's what we have here. Now the question says we should further on solve for what? Y. Where x is equal to what? 8. Where x is equal to what? 8. So therefore y equals to for cube root of where x is what? Is to put wherever we see it to put in there. Therefore our y is now equal to what? 2. So that's all. So let's take now there's another set of questions or a nature of question that normally instead of them writing the question in the statement form like this, they will put the question in a tabular form for you to solve. So let's take one example on it. Let's take one example. So that one will be example 3. So let's write example 3. Let's and take question of that nature and see how it goes. So example 3. So y values directly with x. So we have a table like this. We have a table. X and y. So we have 2. This we have 1. This marks 5. Then we have 2. This marks 10. Then we have 15. We also have 20. Find the missing values of x and y. Now, whenever you have a question of such nature or of this nature, you still have to calculate for your constant value. They say, first of all, you write the relation that you were given in the question. First of all, write the relation down. So each relation, they say y varies directly with what? X. So it becomes y equals what? K what? X. Now to solve for k, we are going to have k equal to y over what? X. Now, from here, to solve for k, you choose any 2 points. If you choose y, you choose its corresponding x, or if you choose this x, you choose its corresponding what? Y value. Somebody can choose to use the first point. Somebody also can use the what? The second what? Point, and you still get the same what? Constant value. So somebody can choose to use this x and this corresponding y. Somebody also can choose to use this x and this corresponding what? Y. Are you okay? And you still have to get the same what? Constant value. So in so doing, let's use the second point or the first point. So using the second point, we are going to have, so therefore our k is now equal to, now y is what? 10. You put your 10 there. Then over x is what? 2. Therefore, 2 to 7, 1, 2 to 10 what? 5. Therefore, our k is equal to what? 5. Now, after you've done solving for k, we substitute the k back into the equation. That equation. So, we are going to have y equals, now k is what? 5 times x. Now from here, you can solve any missing value at all, any value that should be asked to solve. But now they say you should find the missing values of what? S and what? Y. Now when you come here, we are solving for a missing value here, but it's in which component? It's in what? S component, meaning we are solving for what? X. When we know that it's corresponding what? Y. So when you come here, we are solving for x, but we know the corresponding value for y. So y now becomes equal to, so when y equals 15, when y is equal to 15, we have, so it becomes what? 15 equals to what? 5 what? X. So we want x, not 5x. So we divide both sides by the coefficients of what? The x. So here by 5, here also by 5. Therefore, our s is equal to what? 3. Therefore, meaning the value here is what? 3. So let's solve for the next one. So they said we should find for x where we know y to what? 20. So when y is equal to 20, then we come back to what we have here. So whenever you see y, you put 20 there. Comes 20 equals to 5x. So you want x and not 5x, you divide both sides by what? The coefficient of what? The x. So here you divide both sides by 12. So therefore x is equal to what? 4. Now, the last missing value, they say we should find is what? Y coordinates. Is in the what? Y coordinates, the y value. So they say we should find y. When x is equal to what? 5. So we say when x is equal to 5, then we are going to put this inside the equation. So we are going to have y equals to 5 times what? X. So 5 times this x, value which is 5. Therefore, we are going to have y equals to 5 times 5, which will give us 25. So these are the nature of questions that can be set on direct valuation. And this is the end of the first part of the valuation. And the next time we meet, we continue on indirect valuation and the joint valuation. So if you have not subscribed to my channel, please kindly subscribe to my channel for more content. And like it and share as well. Thank you.